And welcome. It's Monday night. Pine Island Research coming to you from the Untold Radio Network Studios. Welcome to everybody who's shown up in chat. They're starting to pile in as we speak. Appreciate you guys making the decision to join us and be a part of the show. It's going to be a good one tonight. I'm excited about it. It's a subject that is something that I've been trying to develop more knowledge of over the past couple of years. My research I did a year and a half ago was really designed around that. And the research project I've got coming up here in the coming 12 months is also designed around it. So I'm excited. I think when we think of all the different things about Sasquatch and Bigfoot, what could really move that ball forward? I appreciate videos, photographs, audio recordings, castings. I get it. I love it all. I think even really good samples of each of those categories have a chance to win some people over. But if you're talking about the definitive push the ball forward, I believe that rests in a DNA-centered effort. But then again, it's one that has to be done right. It has to be done right. It has to be calculated. It has to be done with integrity. And unfortunately, there's been cracks in the past efforts that have exposed that and made them vulnerable. So, but you look at how quick this technology is evolving. I mean, it's just at liquid light speed. It's just crazy. So I'm excited to bring up our guest tonight, Darby Orcutt. He's a professor at North Carolina State University, and he is spearheading an effort, a DNA project through the university. We had him on my show last year before it was part of the Untold Radio Network, where me and Darby spent the evening talking about eDNA and the differences between eDNA and DNA, trying to tackle some of those misperceptions I think people have. What is it capable of? And even more importantly, what isn't it capable of? Because there were people saying, you can take a vial of water out of a creek and tell what pooped in it for 100 miles upstream. No, you can't. It doesn't work that way, And so we really had a great show that night, and I'm hoping we can continue that here tonight. Hey, Darby, how are you doing?
Hi, Jeff. Delighted to be here. Thank you.
You remember our last show last year when we talked about that?
I do.
It was a fun show.
Yeah, it was. You asked me some very interesting questions and posed some things to me that I hadn't heard before. So I really appreciate it.
Well, I mean, maybe you've probably experienced this more than anybody, that it's not so much people in this community of Bigfoot and trying to find answers and trying to really be a part of an effort to answer questions, who are considering, DNA of some sort of effort. It's not so much what they know about it, it's what they don't know about it. I mean, there was a lot of people who say, well, eDNA, you can do this and you can do that. And it's like, I don't think most people really grasp that well,
Yeah, well, it's interesting because I think that there are so many amazing things that we can do with DNA study now. And I think because there are so many amazing things that we can do and have done, it seems almost like a magical science to people. And so I think it's easy for people to assume that it can do, well, if it can do this amazing thing, well, wow, it must be able to do this amazing thing too, and that amazing thing. And I think it's hard for non-specialists to really keep up with, okay, what can we do? What's still beyond our reach? And it's interesting because I work with a lot of forensic scientists, and in forensics, there's there's this phenomenon called the CSI effect. The CSI effect is something that was first noted among juries, where when juries were seeing evidence, they could hear this case. You could bring up 50 eyewitnesses who said, "Oh, I saw this person murder that person," everything, and yet the juries would still be asking, "Where's the DNA evidence?" Or,
Yeah.
"Why doesn't it work the way it works on the CSI TV shows?"
Mm-hmm. Mm-hmm. And then it also, you see so many cases being brought back to life. I mean, you'll have somebody sitting in jail for 30 years and their case has gone back over, and because of samples that were evidence that was preserved well enough, they were able to test those samples and clear that person as a possibility through DNA tests. So that kind of plants the seed that, oh, anything that's 30, 40 years old can be tested. That isn't the case either, So I think that the one thing that I've learned over a couple of years of trying to educate myself more and more on it is that there's very few things that are resolute when it comes to specimens. That means if it works for here, it'll work here, 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 and here. That's not always the case. And I also remember when we talked last time about, as an example, like a little drinking hole of water, you'd think, well, if anything's drank out of there, it's left DNA. However, you could take a sample of that and there could be literally 50, 60 different vertebrate mammals that have put DNA into that. I mean, the ability to test that is really difficult,
Well, it's and I think one of the things that I remember that conversation that's really true is it's not so much even that the ability to test that is so difficult, because it's time consuming and so on. But I think people assume with eDNA, they assume that the methods that are being used are these deep methods that are going to find, for example, everything that ever drank out of that water hole. And it is still the case today that most eDNA studies are targeted to a particular species or particular few species. And so they're testing specifically for that. They're not looking to see what was everything that drank out of that water hole, at least not all the time. Most of the time, it's targeted.
Yeah.
And as we talked about last time, I know you had shown me a study, and we talked it through where right in the protocols for the study, they were saying that, well, hey, anything that's primate DNA, we're not going to look at.
Yeah.
Because the assumption was we're interested in the wildlife in this area, and anything primate is going to be human.
Yeah.
Was the assumption.
That study was,
and that's really outside of the study.
Yeah, that study was designed to see to study virus transfer amongst vertebrate mammals and avian species. They didn't care about humans. They wanted to know what if a tick or a mosquito were to land on a mule deer and take a blood meal and later on land on a rabbit, could it transfer a virus that mule deer had to that rabbit? They didn't care about virus transfers to humans and humans back to the mammals. That wasn't part of the study. So any DNA sample that showed that the blood host was a human, they just threw it away, or even had human elements to the DNA, they threw it away.
Yeah.
What's interesting that you brought up is you really, when you're looking at a targeted species, not really trying to see how many things drank out of this puddle, but did this thing drink out of this puddle? You're trying to identify a genomic imprint for that thing, but you're also trying to utilize the process of elimination of all the things that this imprint isn't. And I think people get confused by that maybe a little bit, because when you're talking about an unknown primate where we don't have a genomic imprint to compare and use as a resolute reference, we're talking about a species X. We're trying to find a genomic imprint collected here off of this sample that happens to be identical to one collected off this sample. And now you start showing there's something there that's alive that we don't recognize yet, but it's in multiple locations now.
Yeah, I mean, and that's, what I say about eDNA is that eDNA is if you're looking for an unknown species, it's certainly a way that one could use. It's certainly a technique that could be used to do that, but it's a fairly hard row to hoe, because you do have to find what are those unique sequences to that unknown, and you don't know what they are heading in, and you can somebody who's doing who's really a good eDNA researcher can do that with a sample, but that presumes, one, that you have collected a sample that has that in it. Which, and then also, say, identifying that, and also that not only has that in it, but that most eDNA that you find in the wild is degraded to some extent. So you don't know that, has the part that is truly unique about that species been part of what's degraded. And, so one can do that work. It's very intense. It's very expensive, because you have to run all of the sequences and the sample. And so the way I talk about it is this: imagine you're looking for an unknown phrase that's similar to a phrase that presumably, but you don't know which phrase it's similar to, and you're looking in a massive Word document on your computer. Well, you can look through that entire document and another entire document, and you can try to find where these match up, and one can do that. But imagine the flip side: you're looking for a known species. You've got a sequence. Okay, well, if I know the exact phrase that I'm looking for in a big Word document, I just put that in the search box, and boom, I found it.
Yeah.
So it's, that's a metaphor. I'm not saying it's exactly, doing this work is exactly like that, but it is so much easier in an eDNA sample to find the known quantity.
Yeah. It exemplifies that a reference exists. It's just finding the reference. It's it's documented. It's there. It's as we talk about this, it kind of reminds me of a conversation that that I had with Eric from Media Palace, who had went and identified this old stone building that had no openings for windows, had an old steel door on it and a lock, and it's buried in the middle of nowhere. And there was a bunch of disappearances in that area. There's a bunch of Bigfoot sightings in that area. And this thing had a dirt floor in it. The lock it locked from the outside. So either somebody's storing something in there or is keeping something in there. And he said, it would be interesting to do eDNA samples of the dirt floor in there. And that, I thought that was interesting, because it kind of exemplifies what would make one target be more of a higher value than another target. Taking an enclosure like that and sampling the dirt. Now, obviously, like you say, stuff deteriorates over time. But if something was being held in this area under that type of a structure, I mean, this thing was made that you weren't going to get out of it. It would be interesting to find out what he'd find in the dirt versus standing on the edge of a forest saying, let's get some dirt samples to test for eDNA. Where do you start, right? He kind of had a spot that had some intrigue and kind of made you wonder. Because it's covered and it's not completely exposed, I think that it probably would have been fairly testable, so to speak. But then again, you don't know how many people have walked in that building over the last 100 years and took a pee themselves on the floor, But if something would have been in there, let's just hypothetically have to speculate. If there had been a Bigfoot in there and it slept on that floor and sweated on that floor and peed on that floor and drooled on that floor, do you think that dirt, if that had happened, that it's likely that you could get an eDNA reference of what that it was there?
I mean, I would turn that question around, and I would say that I would think that it would be the real question is, what was this building perhaps used for? What
Sure.
was held inside of there?
Yeah.
And I think that an eDNA sample of that dirt would probably go a long ways towards answering that question.
Sure.
Of course, there are a lot of factors, like, you don't know. I mean, I don't know, and I've never heard this situation that you're talking about. I don't know if this was something that was 10 years old or 110 years old.
This is about 100 years old, and he had done some research on it, and it looked to be something that was somebody or something was being held, was being captive in this thing. Whether or not that's humans, whether or not that, who knows? It could have just been that they were locking up liquor during Prohibition. I don't know. But I guess the thing is with this thing being locked and the door always being shut, it's not going to have deer pee and all of the stuff that you would get on the open forest floor. It seems that whatever evidence would have been in the dirt likely would have been whatever was held in there, if it was a living thing that was held in there. But
and the other thing is that certainly DNA degrades over time, and really so much depends on the conditions and the climate, the weather, the moisture. If it were 100 years ago and a damp floor, and you had regular seasons there, I would say that, wow, that would be probably a lot more difficult than if you're talking about something fresh. But the thing is that you never truly know until you test it, until you ask the questions, until you look at the samples. You don't know what you have or don't have.
I think that's one of the unique things you have going on with this project, and it's kind of the unique factor of the project that I'm trying to put together in the coming year, is that we're not stapling a $10,000 check to each sample. You've actually got a lab and
two labs.
And you've got a number of people who are willing to approach this from a non-biased standpoint and say, look, we're going to follow the data and show you what it shows. There isn't somebody writing a check saying, man, I really hope this is the outcome that it showed. No, this is a very neutral approach to testing these samples and trying to figure out what you've given us. And I'm curious if I could ask you some questions about samples themselves, because lately I've seen a lot of interviews with Melba Ketchum and her ideas and thoughts on samples and what could be tested and things like that. We've got some people who have some thoughts on different ideas of what samples are better to test than others. Look, I think last time you were on, we talked about scat and things why sometimes they're very hard to test because a scat sample is going to give you in to some degree a menu list of everything that animal consumed probably over the last 72 hours or more.
Yeah, but scat is certainly one of the types of samples that we're anticipating will be offered to us.
Yeah.
But yeah, I mean, certainly there are certain types of samples that would be more likely to be able to yield a definitive result than others.
Mm-hmm.
I think that there's certainly certain features, and again, how long has a sample been out in the elements before it was collected?
Sure.
How old is it? How has it been stored? How was it collected? How has it been stored? Particularly, if somebody's had it, sealed in a plastic bag in their hot garage for 10 years, it's unless it's bone or tooth, it's probably not going to
goes
yield
away
much
pretty
anything.
quick. Yeah,
but but these are the things, and at this point we have a call out for interesting samples. We're not mandating that they be collected or preserved or stored in any particular way. We're going to consider all those things as we prioritize which we're going to take a look at first.
Sure. Yeah, we're going to go over that so that everybody sees what the form you're actually going to fill out if you're choosing to send Darby a sample, and kind of we'll get your input too on maybe some of the vetting process that incorporates itself into looking at how those are answered. But one of the things I wanted to ask you about is something that I've heard Melba say a couple different times on interviews, and that's that she felt that really the only part of a hair sample that could really expose any type of DNA result was the follicle that may hold skin cells on it. That she felt that the core being void of a medulla core and whatnot, that there wouldn't be DNA anywhere else likely on the sample. I don't know that I share that opinion. I'm curious if you have an opinion on that, or.
Well, I do think that the idea that the a hair that is plucked rather than a hair that was shed is easier to extract DNA from generally is absolutely the case. That is true. I don't think it is any longer the case that you can't possibly derive DNA from a hair that may not appear to have those attributes. But yeah, it is certainly much more difficult to so.
Well, I think she's correct in that the follicle end, if it's fairly recently plucked, especially, is going to have a tissue connection to it that has skin cells, that has lipids, that has the skin oil in it, that obviously is a much better sample to test than the follicle of a hair. However, I kind of feel like once that hair, if it was shed or if it was plucked and sat out in the elements for 30 days, that skin cell end does not last that long out in the elements. I would say it's not any more testable than the rest of the follicle, but
perhaps not. I mean, and that's something that as we look at these things, we're certainly going to prioritize some samples over others. But I wouldn't say that again, the wonderful thing about this is that I have as collaborators in this project. Really top notch
Yeah.
people. So
you want to tell us a little
basically-
bit about, is it Shelley up in, was her name Shelley? I forgot now. Up in Canada that looks at the hairs and actually, without doing DNA tests, but actually looking at the hairs and studying them.
Yeah, well, there are a number of folks. You're thinking of Cindy Dosen.
Cindy, yes.
Cindy is a citizen scientist up in Southwest Canada. I can't remember exactly where she is. Near Vancouver, in Vancouver, the island area. But she, she's a citizen scientist who's looked at a lot of hair and is really good at figuring out what species something is from the hair alone. It's something of a lost art these days. There are not too many people who can do that. She has trained herself amazingly well reading the science straight, and so she definitely has a lot of expertise in hair analysis. And that's one of the things that I think is interesting, is that she has looked at certain hairs, and they're very, very, very few hairs that she's looked at that she can't attribute to a known animal. And those few hairs that is the case for, she reports them sharing certain attributes with one another. That's an interesting question, because they share these attributes morphologically, or visually when you look at them microscopically, doesn't mean necessarily that they are the same species. Doesn't mean that any of them are necessarily an unknown species. But these are interesting questions, and certainly those things are possibilities. So this is part of what we're wanting to look at, are these samples that appear unusual.
Yeah.
We're every sample that somebody offers to us is a sample of something.
Sure.
Whether it's a known, whether it's an unknown, or whatever.
There is an
We're
origin.
interested in determining what they are.
I think kind of reminds me, because I think that's some of where Doug's vetting process that he uses when he's looking at hairs. You got to understand that when you look at a hair follicle, it'd be very difficult to look at a hair follicle and say, because I see this, I'm led to believe it's Sasquatch. Really, what you're looking at is saying, because it has this, we can eliminate these origins. And because there's this, we can eliminate that. And it really starts narrowing the landscape as to it being like I said earlier, not to overuse the term, a higher value target to test, so to speak. Doug would often talk about the scale pattern around the follicle of the hair. Meaning, if I remember this right, there were 6 or 7 scales around the follicle of the hair on a human hair. Didn't matter what country you're from, didn't matter what skin color, didn't matter if it's red hair, blonde hair. But when he was looking at follicles of what he believed likely could be Sasquatch hair, there was only 5 scales in the around the diameter of the follicle. Now, that became kind of a vetting process for him. It's not to say that this hair can't be a Sasquatch hair, but if he saw one that had 7 scales around it, he knew that it could be more likely that this hair came from a human, possibly the human who was involved in that process of setting out and looking for hair. And so when you start saying, like in your case here, eventually you're going to have a lot of samples sitting in front of you. Where do you start?
So.
Where do you start? Well,
that
you got to have a process that kind of says, let's slim it down a little bit so we can say, here's the ones we definitely want to test first. So,
well, at the same time, though, Jeff, I think that we have to be very careful about assumptions that people make. And I think you've mentioned a couple of them already. Scaling patterns. The idea, scaling patterns are not necessarily, this is what the hair experts tell me, not necessarily as indicative of species differences than people seem to like to say. I've also one of the folks that I actually managed to track down about a year or so ago is Dr. Henner Fehrenbach, who you may remember from his appearance in the first Legend Meets Science movie
yeah.
that Doug Hychek you mentioned produced. He actually has tremendous expertise in microscopic analysis of not just hair, but of all kinds of biological samples. He has probably looked at more alleged Sasquatch hair than anybody. And yet, Dr. Fehrenbach tells me that in his opinion, the scaling, there's nothing to do with it. He does not think that's useful as a way to differentiate known from unknown species.
Has he ever commented to you on his ideas of what most people will, you hear it said almost to a cliche point, that there is always a lack of medulla core? Is that really necessarily the case?
No, he doesn't necessarily believe that either.
Yeah.
And again, this is someone who's looked at more alleged Sasquatch hair than probably anybody. So, I mean, again, these are interesting questions, but we really don't know at this point. So lack of a medulla and scaling patterns, maybe they are indicative of certain types of something.
Or even the majority.
Or hairs from a particular part of the body or something like that. But as a hard and fast, way of differentiating, what might possibly Sasquatch hair from what isn't, it's absolutely premature to say that, just as I would say it's absolutely premature to say that there even is an unknown species that we call the Sasquatch.
Yeah. Well, I think that I had a theory or a hypothesis that I wrote about in my book that referenced, and I'm not talking about that middle 2/3 of North America. I'm talking about the extreme heat in the south and the extreme cold in the north. If you look at detailed descriptions of what people have seen, when they're described in detail to people like Larry Batts and the different artists who try to draw them, you start hearing representations that I don't want to generalize here, but when you start talking really far north, the size, the height, the body mass just seems to, the descriptives seem to be a little bigger on average. Down south, you start hearing when they describe the hair on the top of the head, a lot of times it's not long and flowing. The hair doesn't hang way down off the arms. You start seeing descriptors where it's kind of spiky hair, or it stands straight up, or it's thicker, Whereas up north, where it gets 40 below zero wind chill and a couple feet of snow, it seems to be longer, more limp, lays on the body. It has just a different descriptive to it. The hair's flowing down the sides, and it makes sense to me when you start thinking. I've talked about this several times on this show. when you look at other species, a white-tailed deer, a 7-year-old buck in Alabama, it's full mature size compared to that same species of white-tailed buck in Montana or North Dakota. One, it's corn-fed and it has a different forage base, but it also has really difficult winters. It takes an extreme metabolic rate and caloric intake to sustain itself through those 4 or 5 months a year. And we see a 40% size and mature males difference, and it's the same species.
Yeah, and that was one of the things that actually Dr. Fehrenbach published an article back in, I think it was about 1999 or 2000, where he looked at Sasquatch reports, and he looked at the estimated size given by witnesses, and he found that there was that same pattern, that similar pattern we see to known species of a certain amount larger in northern climates and smaller in southern climates. And he argued that correlation in reports of Sasquatch was an indication that we could be talking about a real species.
Yeah.
And that is a it's a probabilistic argument, but it's a fair argument.
I think
that's one of the things that makes the subject very interesting.
Like a lot of species, I mean, when you look through the middle half or the middle 2/3 of North America, you might have representations of both. It just simply doesn't get cold enough or hot enough at long sustainable enough times that it would create a dominant trait in size and things like that. But it does explain this shorter hair length. If you think about it, in Florida, in these hot states, it has to ventilate its body heat. And in these extreme northern climates where it gets cold for so long, it needs to insulate its body heat. So longer up north, longer, thinner hair that drapes and insulates makes more sense. Down south, maybe less follicles per square inch, and even a core that allows the hair to stand up off of the skin before it bends so that it can insulate itself. Kind of leads me to think there's a better chance that you could have a medulla core in a southern, extremely hot southern climate than maybe you would collect up north. And I just kind of never really focused on that much till a researcher that I know in Florida pretty well showed me some hair samples that he'd collected. They look nothing like the hair samples I've collected. They're shorter. They're dark. There's not a lot of translucent look to it. And yet when you hear the method that he used to collect them, you think, man, there's a pretty good chance that these actually are Sasquatch hairs. So, that pulled me off of the don't apply one rule to everything method,
Yeah. Well, and that's why, honestly, part of why I was excited to put this study together is because we are in a situation where folks are, they're making arguments, they're trying to make assumptions, they're trying to put things together in a environment where, quite frankly, there just really isn't a lot of data. And part of why there's not a lot of data is there hasn't, for all of these alleged samples that have come to people, that people collect. I had people ask me, years ago when I first thought about this, they were asking me, well, where should I send this to be tested? And quite frankly, there wasn't a credible place I could recommend to do the work. And I mean, don't get me wrong. I mean, there are plenty of wonderful commercial labs that can do a great job of identifying known specimens. Particularly one of the things that was that I had a Bigfoot investigator who had found a ball of hair, and he said, well, I took part of it and I sent it to one lab on the West Coast, and I took part of it and I sent it to this other lab on the East Coast. And he didn't show me he couldn't find the report from the West Coast, but they had said it was human. He showed me the report from the East Coast, and they had said it was wolf. And it was found in a location where wolf would be highly, incredibly unlikely.
Mm-hmm.
But he was concerned. He was like, well, why am I getting two different answers for lab tests the same ball of hair? And I said, well, it's possible that, you've got a ball of hair, and what you think of as one ball of hair could be nesting material or something. It may have multiple types of hair in it. So maybe you did happen to send human hair to that lab and wolf hair to that lab, and they were both correct. That's a possibility there. But also looking at the wolf report that he had gotten, which again would have been very strange. I mean, for where this was found. Reading the report, I wasn't convinced that the lab had really done a great job for various reasons. And I suspected that maybe that was a case of this was a lab that was happy to collect people's money. They were happy to say, oh, okay, this is kind of close to this. There's the result. And, and we see a lot of this is that people say, okay, well, and you see this in a lot of TV shows, they had it tested and somebody came back and said it was this. But you never see, and it's never released, the sequence information. You never see the underlying data from which that interpretation was made. And so science is about going back and being able to look and see, okay, this was the result that came out. Now let me look at it and check it and make sure the work was done right. And if you can't do that, you just, I don't know, do I trust that lab? Do I trust, then it comes to that. And that's, and that's a little shaky when you're talking about, samples that are potentially of an unknown species, because folks who aren't really trained as researchers, folks who aren't really, research geneticists, and so that's why I was determined to get the right people, absolutely top-notch, world-renowned geneticists, genomicists working with me on this. I've got two folks who are just absolutely tops. I mean, just amazing. I've got a microscopist who's working with us that I found kind of late in the game, who does amazing, I mean, just amazing work, and has the setup. He can actually do light microscopy to the molecular level, which a couple of years ago was impossible. Or a few years ago, I don't know how many years ago, not long ago, was impossible. And so so I mean, we've got folks who are capable and have the expertise to really look at these things. I've also got a whole collection of people who are on deck, if you will, who are not part of the study at this point, but who are ready to jump on board depending on the types of samples that we get. So if we get an interesting bone or tooth sample, I have just an absolutely outstanding osteo specialist who is excited to look at that. But if we don't get bone or tooth, she can't contribute her expertise. But I've got several folks who are ready to sort of come out of the closet, if you will, scientist, if the right samples come along. And I'm hoping that they do. I'm hoping we have some things that will be interesting. Whatever they turn out to be will be very, very interesting.
Well, I think one of the things that you mentioned was, when you've looked at results and you've looked at past efforts from different labs, especially when you're talking about results from tests that were basically the guy off the street walking in saying, will you test this for me? Here's the check for whatever it's going to cost. How much integrity goes into that process, and you'd be
and how much expertise too.
Well, that's just it. You'd be pretty naive to assume that they're all done at the same level or even at a good level, because in every industry that's out there, that's not the case. There are a lot of places who will take your money and appear to have done their job. And really, you find out in the end, maybe they didn't do it so well.
And that's what I was afraid of. And that's why particularly especially that one report that I looked at, just the way it was written, and it didn't scream professional to me, even though it was a commercial lab.
Well, and if you're doing it with somebody who's going to do it at a professional level, with a process that protects the integrity of the whole project, I think you should be able to expect relatively a thumbs up or a thumbs down onto the answer you're looking at as per what that sample is. You guys are going to figure out what it is. Most of the people that are giving it to you from this community are, is it Sasquatch or not, right? For you, that's not the question. The question is, what's the origin?
Right.
Everything
Absolutely.
on the table, what's the origin, right?
Yeah, I mean, don't get me wrong. Would it be absolutely amazing to be able to say, oh, we found an unknown creature that fits the profile of Sasquatch? That would be an absolutely incredible result. I'll take it all day long.
Sure.
But when you go into a study like this, the question has to be, what is this? What are these things? And there are a number of very interesting results that we could find. There are a lot of interesting things we could learn. If nothing even seems to resemble Sasquatch, there's still incredible things that we could potentially learn through this study. But yeah, don't get me wrong. I'll take finding Sasquatch.
Sure.
It's funny. I told my collaborators from the very start. I said, look, I mean, if we happen to find something like that, the nice thing about it is we've got a guaranteed publication in Nature, which is the top journal in life sciences.
Mm-hmm. Well, that is an interesting point that, you really don't, that's the one variable that you really don't have control over, is there's going to be a huge variable that exists in how different samples were collected, how they were handled, how they were maintained. Was it collected in a 10-hour window? Was it collected in a 10-year window? Right? There's so many variables, and then you've got the possibility that is real that somebody will give you samples that they know aren't Sasquatch hairs, or they're trying to fool somebody. I mean, that's one of the interesting things. And I would like, before I say this, I would like to say, if you've got samples and you want them tested, send them to Darby. Because the project I'm working on the next couple of years, the samples don't come from human collection; they're from vector. Okay, this is kind of a once in a lifetime opportunity here for somebody to get involved in this, right? at least somebody like me, the guy off the street, right? I don't have a lab. I'm not a professor somewhere. But one of the interesting things about what I was going to be working on with vector collection is that they're all collected by mosquitoes and they're all going to be blood samples. And if we test 10,000 of them, the way that I got these scientists that aren't from the Bigfoot community, they're using this technology like you had referenced already. This is something that all the samples they were throwing out, the human ones, were the ones I would have liked to have had looked at, right? So I wanted to kind of flip the script and design something to throw out all the other vertebrate mammal samples, but really hone in on anything that isn't recognized that could be part human or human-like DNA. And the interesting thing about mosquitoes is they're not in it for the fame and the fortune. They're in it because they're hungry, right? I mean, that type of a thing, you have what you have. If you can collect 10,000 mosquitoes out of 100,000 that have had a blood meal in the last 8 hours, you've got a sample to test. Something like this is really exciting because you have people who have found stuff over the years and they've vested themselves, they've vested themselves somewhat into these samples, either the efforts it took to collect them or just that curiosity of what do I have here? And this is an opportunity to get it answered. But we simply can't protect the thing from having samples sent that simply are known not to be Sasquatch. They're just sending them in because they want their name on a sheet, or they think maybe I'll get in this or that. I think it's very important that this is a challenge for you to some degree, because you want everybody to know that they're welcome to take part in this, that you genuinely want to look at what they have, but there still has to be a vetting process in place. That's why the questions exist on the form that you're asking them to send out. Absolutely. And I'm going to bring that up because I've looked it over and I think it's very well thought out. Let's see if I can blow this up a little bit. It is.
Yeah, we tried to keep it balanced between gathering enough information and not asking people to, have to fill out too much.
Yep. I think we can go that wide and still cover this. So basically, when you and we'll put the link, I'll put the link in the comments, I'll put the link in the description of the show here, and also there's going to be some contact information for Darby too, other than just this link. But this link brings you right to the page where it has a survey that it's going to ask you to complete. Now, let's just get this out of the way. The first thing it's asked for is, what is your name? And I know me and you have talked a little bit about somebody who might want to be anonymous to some extent. They're not interested in having their name out there. For instance, if you show that this is really an interesting result, they don't have to worry about their name being in a magazine article or on a documentary. You're willing to protect people's identity if that's what they wish?
Absolutely. And in fact, in a moment later down, folks will see the question where we ask how or even whether you'd like to be identified, because that's the thing. I know that there are some people who really want to have credit for the things that they find. And so, if you want to be publicly acknowledged in the study and connected with your particular sample and the results, what that is, you just check that box and And I absolutely believe in giving credit where credit is due. So
Sure.
if you want to do that, great. If you want to, and some people will, I imagine, will want to make it, have their name there as, hey, I contributed something to the study, but maybe, and in any case, anybody who submits a sample they will receive the results of what their sample is. But some people may choose, okay, I want to have my name as somebody who contributed to this study, but I don't want my name connected with my sample because it might turn out to be a bear, and I don't want to be embarrassed that whatever. I mean, it's up to them. But the other option, and what you're alluding to, is if they want to remain completely anonymous. I mean, I'm asking them to put their name on here just for the research team. And honestly,
Sure.
there are only 5 people right now who are authorized to even see the names. And quite likely there'll only be 2 of us who ever see the name and connected to what sample number it is.
Sure. And I would
we're keeping that
imagine
absolutely confidential for the folks who
I
want to be.
would imagine that somebody who wants to be publicly anonymous still wants to know what the result is on the
and they will
sample
receive
sent
their
in,
results.
and you would have to
Absolutely.
be able to contact them and maintain that connection
Exactly.
with them. So, there needs to be a level of trust that is there, that they get to control the exposure that they receive. It's not your
Absolutely.
decision. So,
And that's part of why it took, it took me years to get this together, because I had to get the right people. I had to go through a lot of paperwork with the university, of course, and that's something that the university has as part of the plan, is how will you keep people, private, the information that
sure.
people want to keep private. So we have to have a very strong plan for that. There are real ramifications if we don't do that. This is not an individual saying, hey, send me your stuff and I promise I won't tell you. No, this is for real, like very,
Sure.
a university study. So
Well, the first thing that it asks is, what do you have a sample of? For this purpose, a quote sample consists of a single piece or grouping, example, a ball of hair or a pile of bones, found at the same location at the same time. And you've got some areas that they could identify as far as hair or fur, bone, tooth, blood, flesh/tissue, handprint, body print, residue, scat, saliva, a body part, which that'd be interesting, an entire body, other, and unsure. And, unsure, that makes sense. I mean, honestly, if you're looking at, I'll just give you an example. I recently found, I shared it last year, a picture of it. I found a jawbone that when you put it next to like a soda can, it was a little bigger than that in length. But what was really interesting was the teeth that were in it looked flat like molars. And they had a very intricate little, it looked like somebody took a laser and did a design. And I mean, it was crazy how ornate they were. And I showed it to Doug and said, what the heck is this? And we were showing it to different scientists. And one of them got back to us and said, that's the jawbone for a grass carp. If you look at like a 30 or 40 pound grass carp, their teeth are intricately designed with this pattern. But I'm looking at the thing, I would have never guessed it was a fish, let alone what kind of fish it was. So somebody who has something that they're going to send you, they may be unsure of what is this. I don't know what this is.
Yeah, no, absolutely. Absolutely. So, yeah, and that may be what makes it interesting, is that it's unclear what it is.
Well, the entire body thing, I mean, honestly, if you get a refrigerator sized box that shows up on a truck, You may be preparing yourself for the most interesting day you've ever had. I mean,
well, and that's interesting because I wrote the first draft of this, and that selection was in there, and my team looked at it and they laughed, and I said, well, they laughed at first, and they're like, okay, but I said, look, we had to go through, and honestly, I mean, we had to go through this. I had to go through this entire process with filling out the paperwork, and the university. We have to go through what's called the Institutional Review Board, and we have to show that we have a plan in place and that we're conducting the experiments with reason, with the proper ethics, both towards the people who are participating, as well as even to animals and
if
so,
you're going to follow the data wherever it may lead, you can't put parameters around what you may receive to look at, really.
Absolutely. And
a good example of that, you see pictures of it, Darby. Like you see a picture of a deer hanging up in a tree 12 feet off the ground with its guts hanging out. And you're like, what the hell put a 180-pound deer up in this tree, right? And people say, well, it was a mountain lion. Mountain lions will do that with some animals. I don't know that they're going to be able to do it with 108, an adult-sized white-tailed deer. Whatever did that likely left DNA on that carcass. I'd want to look at it.
Yeah.
I would definitely want to look at it if I had your resources and the lab and everything else.
Well, I was also, I'm looking at this as if somebody, hits a Sasquatch with their logging truck and they want to know what to do with it. I mean, honestly, I mean, if I was going to go through all this paperwork and everything, and somebody happened to offer an entire body at some point, then I wanted to be able to take it without going back to the board and having to fill out more paperwork and everything. And so at this point, we are the only university that exists that could probably accept a body right now.
Yeah. I mean, if the return address on it says T. Biscardi, maybe you don't go much further than that. But yeah, I mean, you got to put the welcome out for people that you never know what somebody may be sitting at home, standing in the garage looking at, saying, what do I do with this? Right.
Well, and that's the thing is that, again, I mean, nobody's expecting that we're going to be offered a body, but hey, if the opportunity presents itself, we're going to look at it, and we've got the folks who are going to look at it and be very, very interested in it. Let me tell you.
Sure. Just going through. There's been a couple questions that came up in chat. I have highlighted them, and we will be going back and asking them here at the end. But so don't feel that we're avoiding it. The next question, it says, do we have your permission to test the sample, and would you like to be acknowledged by name and how? In any of the cases, you will receive an oral or written report summarizing conclusions regarding any samples you provide. But there are several selections here that involve a different level of either from full disclosure to full anonymity, as far as where they decide they want to have their information shared.
Absolutely. And again, as we said, we wanted to accommodate however people are. So, and I know that there are going to be people on both ends of those polls. There are going to be some people who are like, I'm real curious what this is, but don't ever mention me. And there are going to be other people who are like, wow, I want to get full credit for having found what I found.
Yeah. So the next question, how large / how much of a sample do you have? The drop down indicates selections such as single hair, single other item, size of a coin or smaller, size of a hand. I think that's important because if somebody says, well, I have blood. Well, do you have a quart of it, or do you have a dried dime-sized drop of it on something? I mean, there's got to be a way to measure the quantitative feature of whatever their specimen holds.
Yeah. And like with most of these questions, I don't want anybody to fret overly as well as whose hand, my hand like
Yeah,
this, my
yeah,
hand like that. Don't worry about it. This is just for us to get an idea.
sure, sure. When was the sample collected? Day, month, and year. We may need to contact you for more information. How would you prefer to be contacted? Email or phone? Is there anyone else involved in the collection or finding of the sample that we should contact? Yes or no? Do you find any? Do you have any supporting documents you would be willing to share? Yes or no? That would be interesting because for me, each day that I went up the Clearwater River, I filled out a complete field report. And the day that I collected
Excellent.
any given sample is recorded what time sunrise was, what time I was arriving at the location, what time the sample was collected, what the temperature was, what the humidity was. That's all on there. And not that any one of that is important, but it certainly helps you draw a picture for that as part of that vetting process of understanding the environment this sample was collected in.
Absolutely.
Uh,
And and this is the thing. And some people have contacted me and they've said, well, we took a video of ourselves collecting the samples. You
sure,
can see how that was done and things like that. If you've done that, great. Some people have just collected samples. They found something. They may not have even really thought about it when they collected it. And so,
sure,
again, we're to go back to that sort of forensics model. If you've got a if there's a crime scene and there, it's great if everything is fresh and collected right and everything else. But at the same time, if you've got a crime scene and well, whoever found it, stepped in the puddle of blood or whatever else, it's not like the investigators say, oh, well, we're not going to look at it.
yeah.
It's still something that needs to be investigated.
The next question is, how was the sample collected? And that is a spot to essay your answer. But this is interesting because it leads me to a question for you. Has the sample been in direct contact with an individual, for example, handled with bare hands? Yes, no, unsure. Let me ask you this. If somebody says I have a hair sample or I have, a physical specimen sample like that, but it was handled with bare hands when it was first found.
Mm-hmm.
The person who handled it, if you had their DNA, would it be easy for you to eliminate and better isolate what DNA may exist in the specimen, or would that not be necessary?
If you were looking in a crime scene environment where you're trying to distinguish, different individuals, it would
Sure.
matter tremendously. In this case, not really. It's good to know so that we can account for that and properly, handle that specimen. But it's not. If you think, I mean, it depends on what the sample is a sample of. But
Sure.
I think we're the sorts of analysis we're going to be doing. We're going to be able to.
It's
We're going to
going
be
to
able to
stand
figure
out.
that out.
Bob Smith's DNA and
Yeah.
the DNA that's on the sample are two completely different genomic imprints, and there is nothing that exists between the two. It's either this or it's this. So if
Yeah.
you knew that the guy sending in touched it and you've seen DNA showing up in the sample that is recognizably human, it's pretty easy to assume that's Bob Smith. Is there something else that exists here, right?
Yeah, I mean, I do think that there are some questions that I mean, it's worth saying that I mean, we're not looking to sequence people, like known people's DNA.
Sure.
So, and nobody has to worry about, if they've handled it with bare hands. We're not going to publish their genetic sequences when it comes time for the study. We're not going to do that because that's just not right or ethical, and it's not part of our practices.
It's funny because, interestingly enough, Darby, that's one of the reasons why the study that I referenced to you and others a year ago threw out the human DNA that was showing up, because they weren't interested in saying, this is Tyler Jackson. He has an STD. He has all these different viruses, when they don't have Tyler Jackson's permission to even talk about him. So
absolutely,
that's why they wanted nothing to do with human DNA that they had collected at that point.
Exactly. And that's again, that's part of the ethics review. It's not important to the study, then it's not something that you want to risk looking at. Now, in the case of this study, there are, I do think about the full range of possibilities, and certainly, so if there is a species or a population that is Sasquatch, then there are a lot of theories as to what that could be. A lot of people have different ideas about how something could have evolved. Of course, did it come from Gigantopithecus? Some people think, oh, well, maybe it's lemurs, descended from lemurs or chimpanzees or what have you. There's apparently I've heard there's at least one novel that presents the idea that Bigfoot evolved from, I think it was opossums. So there's all, certainly the going, probably the most common theory is, some sort of unknown primate, maybe Gigantopithecus descendant, maybe something else. But of course, there's also a lot of speculation that this could be, if this is an unknown species exists, it could be very, very close to human, or even potentially a type of human, Homo something, or even on the farther end of that, it's even speculated by some that that Sasquatch could, these reports could be of human populations that have, Homo sapiens that have distinctive features by virtue of being a distinct population rather than necessarily even a distinct species.
Mm-hmm.
So is it possible that with certain samples, in order to really do our due diligence, we may be looking more closely to modern humans than certainly than other studies do? Absolutely. That's a possibility if it warrants going there. So I mean, I think we have to see what the samples are that come to us, but we're going to treat each sample as the unique and precious thing that it is, because until we know what it is, there's a wide range of possibility there.
Sure. I mean, it gets really easy, I think, sometimes when you're trying to approach it from a flesh and blood standpoint, to simply say, well, somewhere there's an evolutionary slot that this fits into. It doesn't need a supernatural explanation. It doesn't need, the most plausible slot that it would fit into. That's what I want to find. I don't know that is connected to possums, or I mean, it just seems to me, when you're looking at what's the most plausible slot, but when you're talking about the most plausible anything, you still don't know.
And I think
and you've got to follow the data where it leads, and you don't know where it's going to lead.
Absolutely. And that's the thing, is that as I look into this study of these strange samples, I mean, I don't want to. It's like we were talking about, the no medulla and all this. I don't want to make those kinds of assumptions, that that certain things are not worth looking at because they don't look like this or that. I mean, if we can put it under a microscope and it looks exactly like bear hair, well, gee, it's bear hair, right? But for those things that truly have unusual features, and that we're going to be proceeding down the line and doing more and more intensive analysis, um, I don't want to presume. I don't want to presume anything,
Sure.
really.
Sure.
Even the most, if you think about the, whatever anybody considers the most likely explanation to the least likely, well, if it is the least likely, then it is the least likely. What seems the most least likely, because that's what it is. I mean, I think back
Sure.
of in the 19th century, I think of how long it took a lot of scientists to accept the duck-billed platypus, because it
Yeah.
seems so unusual and so strange and so unlikely, and how could it possibly be? And it is absolutely implausible, except that it is.
Can't possibly make its own custard. That's impossible, right? Eggs and milk. Anyways, wanted to touch here. So the rest of the questionnaire, you ask where was the sample collected, and you have space for GPS coordinates if it's possible, if they have those. If not, U.S. state and closest town or city. And then there's what were the
Yeah.
circumstances under
And
which.
actually, Jeff, let me interrupt here, because one other thing I want to say that is very clear is, whatever one chooses in terms of whether you want to be anonymous or whatever, we are not going to be sharing specific locations, period.
Yeah, your backyard
So
is not going to be in
I
U.S.
am not
News
doing that
tomorrow.
to anybody. I am not.
Sure.
So locations, we may share general locations. We may say, oh, like with your samples that you're going to be offering, we say,
Counties,
hey,
state and
northern
county,
Minnesota, hey, that's
sure.
fine. But yeah, we're not going to be sharing specific locations at all.
So, what were the circumstances under which the sample was discovered? There's on the ground, on a tree or vegetation, in water, in the ground, on a vehicle. Um, so, again, it just kind of draws that picture of the environment in which it was collected from. What containers has the sample been stored in? And this is pretty. I think people have gotten better just hearing people like you and Doug and others talk about this enough on different shows, understanding that, you know, paper and cardboard and whatnot are much better to store something like this in rather than something that's not permeable at all, like a plastic bag, holds moisture content, breeds bacteria, things like that. Um,
Exactly.
and then how has the sample been stored? Again, that's important. Probably not super important if you're only talking a couple months or less, but if it was stored long term, the temperature of the environment it was stored in is going to play into that and be important. What motivated the collection of this sample? You have found in an unusual context, has an unusual appearance, associated with a sighting, associated with unusual events, or other. Um, and again, that kind of helps. Did you find it by, like, I've had people say I found hair, on the edge of a table or near a fire
Mhm.
pit at a campground or on a swing set. And it's like, this could be somebody's golden retriever trying to steal their hot dog off the table that left hair on the edge. So when somebody at least helps you by drawing that picture of this is what existed in this environment and the technique and the circumstances, it just helps you put a little bit better expectation level on, is this the likelihood of this being something that...
Yeah, and again, it's very much about the likelihood. The
It's still going to
likelihood
go
that
through the
this is
same
going to be some.
process, of course.
Absolutely, absolutely. But again, we have to make priorities, and we're certainly going to prioritize the things that we think might yield the most interesting results. They're gonna get looked at first, and we're gonna move through as we can the rest.
Yeah, how was the collection of the sample documented? It wasn't documented. It was video recorded, photographed, written record, or other, which is helpful, I guess. I guess that would really play into, let's suppose you do crank it out of the park and actually have something pretty notable here.
Mm-hmm.
There's going to be, the more backstory that you can furnish with the results of that test, probably it's more easily digestible amongst other scientists and other people who you want to look at this, right?
Mm-hmm.
Right.
Yeah, and that goes back to just something that, if I can encourage any investigators to do anything more than a lot of them do, is to record things, record the environmental conditions, record things that you observe, record those things on a regular basis, not just when you find something that you think is interesting, but consistently. Because that record, if and when you do find something really interesting, that record is going to be absolutely invaluable to you and to others.
Sure. And the last thing you have here is there anything else you'd like to ask or tell us at this time? So, it's also probably should note that they have a submit button at the end or a save and return later. So if somebody's filling this out and they want to, before they send it, maybe they want to go get the GPS coordinates. So they look it up on their app, or they're running out to the location, whatever, you can save it and access what you've completed so far and then finish it. So when they send this to you, I know at the top here, you have your email address and your phone number on here, but this is going to an email that you said earlier on your team of professionals there. There's only 5 people that are really going to have access to the terminal data that's provided to you.
Yeah, well, and like I said, right now only 2 of us have that access. The other 3 are really just backups. I mean, that's the other thing. I mean, again, part of the ethics thing is that we have to have that, because if I drop dead and I'm the only one who can make that connection and get back to people, then people aren't going to get answers, and that's not right. So,
yep. So let's go on and talk a little bit about, I'll be putting this in the link too, that people can access. It will, I'll go in and edit the description of the video so that this link is there. I'll also put it on the Pine Island Research Facebook page, and we'll provide, I'll keep providing on our upcoming shows too, so that people have access to it. But
thank you so much.
They need to understand one of the things that Legend Meets Science 2, most people are aware that the Kickstarter that they had put out, they reached a funding goal. They're still trying to achieve some more funding to keep this thing going even a little higher up in altitude. But this project that you have is a separate project, not
absolutely
part of LMS2. But yet they're 2 projects that are running parallel to each other at the same time. So we have that ability for, your results to be featured in the document and things like that. It's great that it's happening at the same time, but the finances that push both these projects are not connected.
No, they're not. And that it was actually just a beautiful coincidence that Doug Hychek is putting together this new documentary at the same time that we I happen to be launching this study with my colleagues. And so Doug and I, as you know, we know each other. We talk fairly regularly. And certainly a lot of the samples that he's collecting and has collected, he's says he told me he's going to be offering for this study. So yeah, we are friendly, and I think we are complementary. But yes, we are not directly connected with one another at all.
Yep. I like the tagline, giving to NC State. It says, with your investment, we will continue to think beyond boundaries to do the extraordinary. Out of the two boxes here, the second one in particular says science, society, and the strange. And if you fill in any type of a donation in that second box, you got a couple different ways that you could pay for that donation. But one interesting thing that we had talked about earlier is find out if your company will match your gift. Now, a lot of people who work for a bank or work for a corporate company, a retail company, will match their donations to nonprofit organizations, in which this one is. So if somebody was to send you $100 and they notify their employer, hey, I've donated $100 to NC State to their lab for research, you say they're a nonprofit, will you match it? They likely will.
Oh, they will. Yeah. I mean, and in fact, there are a number of companies that are, if you were to fill out this form and click that box, you would actually hit the continue button. And so with some companies, you don't even have to ask the company. You can just check them off on here, and NC State will say, hey, we've already got an arrangement with them. But some companies who even aren't on this list will absolutely match.
Sure. I imagine the list is probably pretty extensive. I mean, most of these big retailers like Home Depot, Lowe's, I mean, they all kind of have a policy where they'll match your 401k contributions, and they'll match your contributions to nonprofit organizations. So
absolutely,
I would take advantage of it and double the firepower there.
Well, and I do appreciate, I do appreciate. So I know that there were a couple of folks very early on who, when I haven't been out going hat in hand at all, but a couple of folks who, even when they heard that this was coming, they wanted to be a part of it in that way, and it's much appreciated. It will allow us to do more things in terms of the research and the engagement, the teaching that I do in this area. It's certainly, it's not mandatory, so there's no zero expectation that if you have an interesting sample, not asking you to pay to have it looked at. It's completely separate, but I know a lot of people want to be involved and really want to throw their support behind it, and so that's very much appreciated if folks are willing and able.
Yeah, I think it's one of the things we talked about last time you were on, is just that light speed pace that this technology is advancing at, and it's likely we'll be sitting here 6 months from now saying, well, that wasn't possible when they did that show. I mean, it really is crazy how quickly, and to some extent, for those who are leading the field, maybe you're staying at the front of it. But for maybe some of the labs that are kind of in the middle of the pack, it not only feels like everything's moving fast, but to some extent, they may be feeling like we got to play catch up because there's so many things that are evolving and possible with the technology of DNA. And yet it's a lot of money to keep up with that pace. I mean, the lab there, and I'm kind of curious as to the involvement when you said, "Hey, we want to open this up and do something like this." You know, look, I'm just imagining in my head that it's almost like a scene from a comedy movie where you sit down with the higher ups at NC State and say, "Here's my idea." You know, I mean, what was the initial feedback of that? I mean,
well, I mean, part of that was just finding the right collaborators, and part of that was being able to present things that would be of interest to them and their research agendas, which their research agendas have absolutely nothing to do with Sasquatch, that phenomenon. I'm very interested. I'm very curious. But you know, again, I mentioned I'm working with forensics folks, and they are interested in this idea, you know, certainly of, you know, how to and well, my genetics folks in general, my genetics colleagues are really interested in training graduate students, training PhD students to be able to do this work and to be able to figure out unknowns, because a lot of PhD students, a lot of students go through their entire training and they never look at things that are true unknowns. Like, we really don't know what this is at all. You know, they're looking at questions, but it may be questions like, okay, we know the source of this, but we're trying to find this particular, we're trying to answer this particular question or what have you. But it's not often that you're dealing with a true unknown. And so that was attractive to them as a way to think about working with and training their students. I've been, I got engaged with my colleague who's the microscopist through my work and his work with artificial intelligence, because he's actually using AI combined with microscopy to look at certain features in a way that's much faster and much more efficient than a human, a human could do. But it's very important to train that AI in the right way and all that. And that's where I have some ideas about how we might use AI to push some things forward in forensics. And we're kind of batting around some ideas. And, I mean, it would be really nice. Again, there are outcomes of this project that could have, again, nothing to do with the samples themselves, but the techniques that we develop in order to figure out what these samples are may be useful in all sorts of other contexts. So this is the thing about this type of collaborative research, is that you have to go in it with benefits, with more than one type of benefit.
Absolutely.
And it's so fascinating that way.
That's interesting because I mean, I literally have been experiencing this talking to different professors at a couple of different universities that were involved with that research that was done with vector collection. I didn't come to them and call them and say, "My name's Jeff Harding. I'm with Pine Highland Research. We researched the possibility of Bigfoot." I would have been hearing a dial tone before I finished the sentence.
Probably.
I came to them wondering about aside from normal, probably I shouldn't say normal, but what most labs probably experience in the collection of DNA and testing samples and stuff, we're talking about going out to remote areas and collecting mosquitoes and determining what species of mosquitoes exist there so that we can eliminate that in the process. And then all the collection, the storage of them, you got to get them 1,000 miles from where you collected them to the lab you're going to do the research at. There's a lot of blank spaces I needed to educate myself on. I didn't come to them as somebody who is looking to do Bigfoot research, and I certainly didn't come to them trying to indicate this idea that I'm going to write you a check and here's what I'm hoping to achieve, because to some degree I've already poisoned the water a little bit, if that's the case. I've created expectations to which I hope to see met, that really they should be under no obligation to meet if they're going to apply the scientific method and follow the data.
Absolutely.
And so I had to figure out a way to build value in the idea, and I think I did, is that let's suppose we test 5,000 samples of vector collected blood samples, and you're identifying every vertebrate, mammal, and avian species in that region that it was collected and saying, we've pretty much collected samples of everything, except there are no samples of an unknown primate part human DNA. There just aren't any. And in the end, that leads you to say, we kind of think the possibility that Bigfoot could be a real phenomena, doesn't exist. We should have collected that. I'm fine with you doing that. Because if that's where the data leads you, and that's the hypothesis, the kind of your idea in the end, if the goal was to identify if there's an unknown vertebrate mammal out there, and we've got vector collection blood samples of every vertebrate animal in the region, they're all known, and we haven't found any sample. I mean, at some point, whether that's 2,000, 5,000, 50,000, at some point, they're probably going to be inclined to say, we just don't think it's likely. And if that's where you're at the end of it, I'm okay with that. So now that lab is realizing there's value here for us. We can either be part of showing there is something pretty interesting out there, or we could be part of saying we don't think there is because we should have collected it through this process. Either way, I don't care where you arrive at. Just follow the data. It's not hard to get scientists when they're not being pushed into a corner to say, I'll be a part of that. I think when people from the Bigfoot community say, scientists, boy, they just don't want to get involved in this, it's because you're trying to shove a narrative and an agenda down their throat. They don't want to be a part of that.
Yeah. Well, it's interesting too. I mean, it sounds like a great arrangement because from their perspective, they're also getting a lot of free work from you. It sounds like of collecting these samples that, of course, they can use to answer other questions as well.
You see, Paramedics. This guy reminds me of Quentin Tarantino, so I'll donate, he says. I don't know if you've ever had him thrown out as a doppelganger, but
was he talking about me or you?
I don't know. Paramedic, he's a friend. He's funny. He's got a great sense of humor, so he might have. But yeah. Anyways, but you were talking about, that's what I think the biggest value in your project that people should find is that there is not one person or one collective writing a check saying, this is what we're hoping to achieve. It's not poison. The water is not poison. This is probably the most neutral project that's been developed in the Bigfoot community and designed to apply a true scientific method and move. If the ball can be moved forward, it's designed to move it forward.
Yeah, and that was why I designed it, because I'm, I mean, I confess, I myself am very, very curious about the Sasquatch phenomenon. I when I started looking into it a few years ago, I I spent a lot of time, reading. Of course, I'm an academic, but going out into the field as well with investigators to see what they do, what are the techniques that they're undertaking, uh, and it left me with a lot of questions. I look at the sum of all the data that is there, and I'm not particularly satisfied with any single explanation for this phenomenon.
Yeah.
I'm not particularly. I'm honestly not particularly satisfied with any combination right now, and that's part of why I recognize that this was, to my mind, well, I think you said it well in your introduction. There's a lot of trace evidence you can look at. There's a lot of things like that, but DNA evidence would be the key to knowing whether at least the biological species hypothesis, unknown biological species hypothesis,
Sure.
holds any water. And and again, I mean, this is not a study at this point. This is not a study to test the null hypothesis, which is what you're talking about. To show, is it highly unlikely that there is or isn't there isn't a Sasquatch species. I mean, it comes down to really there are a lot of assumptions that you have to make. Certainly if the samples that people contribute that they think are potentially Sasquatch, if these samples that have these unusual features, if all of these turn out to be known animals, and then does that make it less likely? Sure, but does that, how much less likely? I don't know. I mean, there are a lot of assumptions that have to go into that. I mean, eventually, if you test enough samples, like you are talking about with that vector study too. I mean, eventually, if you test enough samples, it starts to look, it may start to look really, really
It
unlikely,
increasingly
highly
gets
unlikely.
harder to justify.
But the other thing is, if you don't test the samples, which is the state we've been in for, I mean, there have been only
Absolutely.
a handful, really only a handful of samples that have really been even looked at by qualified people, and there's only been, to my knowledge, I think really only the only peer-reviewed published study is the Psych study, which looked at 6 or 8 samples from North America. We don't have, I mean, if there is an unknown Sasquatch species out there and you're not looking at the samples, you're not going to find it.
Exactly.
So we
And
have to look.
and there has been instances that I can recall, at least 3, where well-known organizations within this community have said they've had things tested and never disclosed what the results were, or where was the lab, or who did it, or what was, it's we sent it in and had it tested. But show me. I mean, it's not me. Don't take it personal. It's not me
Right.
saying I don't believe you. It's we can't move the ball if we don't see the results. That's all there is to it. I mean, somebody asked me the other day, what happens if your project, you process 10,000 blood samples And none of them seem to be anything that would support a slot or a genomic imprint that could be identified as a Bigfoot or a Sasquatch. What are you going to do then if they put their thumbs down and say, we just don't think it's likely at this point? I said, here's the important thing. That's my issue to deal with. I had an encounter. I know what I saw, or at least feel I know what I saw. And if that's where the data leads, that's going to be hard for me because I've got bigger questions now, things that I have to deal with. But that's not that lab's problem. That's not their issue. Their issue is to follow the science and the data and say, this is what we've concluded. So that's why I say, in order for there to be a parameter of integrity that protects an effort like this, it just doesn't start with a check being wrote by somebody who hopes that it comes out one way and not the other. I wrestle with that big time. And so,
well, the evidence is what the evidence is, and
yeah,
that's what I want to determine is what this potential evidence is evidence of. And like I say, there are a lot of interesting possibilities there. And again, I mean, it's like you say. I mean, your experience was your experience, and and you're one of many people who report having had this experience. And I don't think, I like I said, when I say I'm unsatisfied with a lot of explanations, I'm unsatisfied with the explanation that so many people are just liars or delusional or something like that. That
yeah,
doesn't
yeah,
it doesn't track. It doesn't track for me. That's not to say that that's not to say that an unknown biological species is the answer, but we can but again, we have to we have to look at that. That certainly seems to be the first question that you ask, and you either that hopefully will either lead to
yeah. Well,
discovery or an actual ability to say, yeah, this is really highly unlikely because we've looked and looked and looked and
yeah.
but until
I
you
think
look,
that from a research perspective, when I look at this, I have to say, here's what I believe is the most plausible explanation for what I'm seeing here. And that's going to evolve. That's going to change. The more data I look at, that should not just stay a straight line. It should change every time I look at data to some degree. I have to correct my perception of things as I learn more from the data. And yet there's so many things that are happening in this community where stuff that is simply a theory or a belief or a hypothesis is being presented as fact. It's not doing this community good when that happens. We're often seeing people taking something they can't prove, and then when questioned about it, they're substantiating it and trying to support it with more stuff they can't prove. I mean, but what it comes down to is, even though that plausible explanation for me changes and evolves as the more data that I look at, it has to start somewhere. And I don't believe it starts with a UFO and a Bigfoot getting off it with an orb flying out of its butt and it jumps through a portal. I mean, that just does not seem like the most plausible place to start. I may
right.
end back there after seeing enough data and say this is where it led me, but that's not where I start. So I that's what excites me about this, because like you had brought up when I said in the beginning, when it comes to castings or videos or pictures or audio recordings, I mean, it doesn't really matter how good they are. There's still going to be people looking at them saying, where's the seam in the suit? Or how come there's only 1 or 2 footprints? There should be a whole track line. That audio sounds like this rather than that. I mean, there's a place to really approach that with a healthy skeptical start. But when you see let's say 4 genomic imprints that are all identical, that came from 4 different specimens in 4 different geographical locations, where do you start tearing that apart? If the project's done in a way that protects the integrity of it, like you said, not 1 lab, 2 labs, right? Not a check being wrote by somebody that already has a reputation or somebody has different feelings about, but it's just an effort that gives the lab the opportunity to say yay or nay. There's no pushing you in one direction or the other. Follow the science, follow the evidence. Where you arrive at is where you arrive at, and just tell us where that is. If we can't learn from that, because I don't think you'll learn as much from anything else. Videos, pictures, it's just not going to do it for these scientists and these people like DNA will.
Well, and the funny thing is, I mean, I have, people all the time like to say, and it's I hate to say it, but it's an old-fashioned idea. They say, well, we need a body. We need a body. But I always say, at this point in time, somebody could put a body on the table right in front of everybody, and what would be the first question to be asked? What does the DNA say that it is?
Yeah, they're going to go right to them. You're exactly right. I mean, how do we know this is what it appears to be? Well, let's check the DNA, right? Because and just so people understand, my thought, and I'd like, I think we talked about this the last time. It doesn't matter how many samples that you test that you find a distinctive genomic imprint from. They may match. Specimen 12 might match specimen 17, might match specimen 28. There's something there that is the same imprint each time. We still can't call it Bigfoot. I mean, it'll be a species X or something until there is a body and there is a control that you can test and say that imprint's the same as these 112 you've libraried. Well, and now we can lay our eyes on what that imprint is. Until then, they're all the same, and it represents something that appears to exist out there, but we really don't know what that looks like, do we?
Well, yes, you're correct, but at the same time, if we're able to determine that, yes, but just take the most common theory. If we were to find that, yes, indeed, there is an unknown primate, okay, and here we've sequenced it, and and it fits right wherever it fits in the evolutionary tree.
Mm-hmm.
And it's an unknown primate and it fits here. And, I mean, at that point, I think for all intents and purposes, species would be proven. Mm-hmm. Because it would be consistent with these reports. It would be, we have the DNA, we know, and so, I mean, everybody would want to, find that species, see that species in the wild, document it, there, all of that. But at that point, I mean, just from DNA alone, just from even again, what's DNA but a very small body part, but a very important one. But just from DNA alone, if that were found, that would move the question from where it sits right now, which is scientifically unlikely, to scientifically likely.
Sure.
In fact,
you're going to answer
really,
one question
really hard
and create
to
1,000 more.
isn't that what life is all about? Isn't that what science is all about? I think, if you showed, okay, there's a species out here, then suddenly, wow, we want to know all about it. We want to learn about it. But that would be a great problem to have. Is
exactly.
being able to have curiosity.
We think we argue enough about now in this community about all the things we speculate about. Wait till there's this one question turns into 1,000 questions. What's the origin? Are we looking at a declining population? Did it cross a land bridge and disperse and migrate to all these different areas? Or what did it originate in all these different areas? And we're seeing remnants of a declining population of them just abandoned in different areas. I mean, the questions are going to be endless once we can acknowledge, we found something that this appears to be what it is,
But if that were the finding, our ability to answer those questions would be absolutely revolutionized.
Well, that, and you would have much more effort dedicated to answering those questions, more funding behind those efforts to find out what the answers are. Actually, it would be the most, when it comes to species discovery, it would probably be the biggest effort designed in this century to try to answer those, if you had all of science recognizing that this is real.
Yeah. I mean, and you could probably argue perhaps ever.
Yeah. Yeah. It would by far be one of the closest, we've had the speculative conversations on a lot of my different shows about, geez, this thing, if the slot it fits in is right next beside us, what rights are they entitled to? Where does there's going to be adjustments made in how it's not the same as, boy, we got to control that population by harvest, the same as we do with elk and black bear and everything else. This is different. This is way different. The protective efforts and all this are going to range from one side of the board to the other. And those discussions are going to be like the Wild West compared to what we're trying to decide on or talk about now. But
no question.
That's why there are some people that argue maybe the best thing that could happen is that we can't prove that they're there because they're safer now than if we humans get involved. I hear people say those comments all the time, and I don't want to say that they're right, but there is a degree of truth there. We're pretty good at messing crap up, But I wanted to touch on a couple of the questions that came in throughout the night. Jay had asked, how can you decide what something is molecularly unless you have something to compare it to?
Great question. And I think this question comes up a lot. People wonder, how would you identify a species if you didn't have a sample of it to, a known sample of it, like from a body to compare it to? And it really comes down to the fact that all life on Earth is connected genetically. And so we actually share a rather large percentage of our DNA as humans with plants, vegetables, the food that we eat. And you can track this on the evolutionary tree. And so if you have enough of a sample of something to be able to sequence its DNA, then you know exactly where it fits among all the species of all life on the planet. And it's, you have to have, again, that's if you can sequence the whole thing. When you get bits and pieces,
the more samples,
that's what makes eDNA work so hard, is that you're dealing with little degraded snips and bits and things, and you have to figure out what goes together, and you're you're putting together this huge jigsaw puzzle. So, but with DNA samples, a complete sample, you at least know the DNA is coming, from the same sample. It's less likely to be degraded like that.
And the more samples that you get, the more defined your reference gets, to where you can draw more conclusions from the samples you look at. I mean, largely that's probably the best example is from the human perspective. When you spit in a little vial and send it into Ancestry, and they tell you your descendants came from Wales and Scandinavia and that,
Yeah.
they figured that out because they've looked at a couple million samples. They couldn't figure that out if they only looked at a dozen of them.
Yeah, and I think that's one thing that people wonder about. They say, well, we know so much about humans and their DNA, and we can do so much, but it's part because, as you say, we have studied humans an awful lot. We have studied human DNA so much. When I have my students do DNA analysis, if they're looking at smaller snippets of things, they get a lot of human hits, even for things that they know aren't human. And they're like, well, why is this? Well, it's because, we share this information. If you're only looking at a small part of the DNA, you could be looking at a small piece of DNA from a banana, and it might match human DNA because you're only talking about 4 letters in sequences. And, it's you can find these connections, and it's again, I mean, it's kind of like I mentioned that idea of searching a Word document. If you're if you're going to find letters that are in the same sequences that are in words that mean totally different things. But the longer that sequence you look at, the more you're going to be able to see those differences.
So Grasshopper asks, if something is too close to human, how do you deep dive into the genome to separate it out?
Well, it certainly becomes a much more difficult process, and a much more time-consuming process. Takes a lot more effort, but it's absolutely not a problem for true experts, and that's why I have colleagues who absolutely are the folks to do this work. Because, and part of that is, I mentioned, we know so much about the human genome. We have, not to say that there aren't gaps in our knowledge. We're still working on that. But we do know so much about the human genome that we have a lot to compare to. So being able to tell the difference between something that might be very close to human, or as I mentioned, even potentially, you can tell human populations apart. It's like, Jeff, you just mentioned about 23andMe. I don't know that that's the best example for research scientists. I think that some of their determinations of origins of people are perhaps a bit premature, have been, at least historically. But
I think it's just interesting that they take something so simple and they give you fairly definitive results, but they're only that definitive because the number of samples they've analyzed are in the millions upon millions, to where they could get that defined and determining what those differences were and where they occurred and what origin they came from. You couldn't have, when they had 10,000 samples done, you couldn't send it in. They might be able to say, well, here's the continent you're from, and that's it. Or they couldn't figure out more than that. But Grasshopper does ask, and I'm not sure who this guy is. Whatever happened to the other DNA guy in Arizona someplace? Do you know who he's talking about? I'm not sure.
I don't. I would be really curious about that. I've been trying to parse together sort of the history of any attempts to
there's a lot of DNA guys out there. There's not a lot of DNA guys out there who have delved into the possibility of using it to identify the possibility of a Bigfoot species. So I don't, assuming that there's a connection to that somehow, I'd be interested in finding out who it is too, but
Yeah.
Maybe he can share that. But anyways,
Now,
I'll
unless,
tell you,
I mean, it's possible, I will say it is possible he's thinking of Henner Fehrenbach, who, after he retired, did move to Arizona for a while.
okay.
And he was in the, somewhere around 2000. He was working with a colleague from Ohio State University on some hair samples that Dr. Fehrenbach had examined. And he was working with a geneticist from Ohio State University to try to do some analysis of that. And they were not able to pull DNA from the hairs in question. And so it's interesting because there's a lot of rumors around that in fact, I think you can even find a website that talks about it, that suggests that they actually wrote a full article and were going to submit it and then pulled it at the last minute. But Dr. Fehrenbach tells me that was not the case. They never got that far. So it's possibly thinking of Henner Fehrenbach, who was collaborating on a DNA study back when, and while he was living in Arizona in his early retirement. But I'm not certain if that may be who he's thinking of.
Yeah. Well, I'll tell you, it's been a fun show, just like the last one we did. I always love having you on because I guess just because I have enough of an interest in the idea that if it's done right, DNA, I believe, is probably the most likely way to move this ball forward. The problem is I feel like the retired race car driver who can't sit and watch a race without feeling like he could have won it, right? Every time I look at somebody's idea or an effort using DNA, I think, oh, you should have done that differently. Oh, why didn't you do that? Why didn't you do this? And so it's just, that's why I'm excited about this, because I think that if you list off the 5 most important things that would have to be there to protect the integrity of a project like that, I think you've got your bases pretty well covered. I mean, we've talked on the show in the past about the importance of duplicating or triplicating the results from separate labs, separate team members, so that there's 2 sources that are producing, here's our interpretation, rather than one simply just mirroring the other. Also, we've got to learn from other efforts. And I'm not here to name names or devalue somebody's current efforts to do something. I'm simply saying that even on the backside of this project, Darby, you'll look at the technology that exists a year or 2 years from now, and you'll look at what you did here and say, we could do this better, we could improve this, or we can utilize this and get a better chance of achieving this. But we have to learn from others' efforts and say, here's where they failed, or here's where the crack was in the swimming pool and why the water leaked out. We've got to figure out what's the best way to achieve this. And I don't think that starts with staying in our corner of the room with the Bigfoot community. We have to look outside of it at science and say, we need you. We need your help. We need to utilize the technology that you're already using, but we can't go at them and say, hey, I'm Mr. Bigfoot lover. Will you have a cup of coffee? They just aren't going to do it, And so I think you're approaching it in a fair way,
Well, and that's the gap that I'm trying to bridge, because the other piece is that, with this study, the interesting things that are to be found are only going to be found if if the investigators out there find them and offer them for study. And so it's a partnership. It really is. And I think that that's one of the things that has interested me for a very long time is partnerships between the general public and science. And part of that is scientists not just getting help from the community when they feel like they need it, but also engaging with that community and also answering the questions that are important to regular people. And so this study will not find anything interesting if we're not offered interesting samples.
That's what I was going to say. I mean,
that's why I'm here.
I think it's fair. Is it fair to say that you feel confident that the success or the failure of this project is not whether or not the lab makes a mistake or funding isn't there or this and that? It really comes down to, are we going to have samples sent to us? We need to have a lot of good samples sent to us to test in order to find the results. Without the samples, it doesn't matter how great the lab is, or it really doesn't.
No, absolutely. And like I said, I mean, if people, I know that there are a lot of people who really are certain, and like yourself, have had experiences where they feel confident that yes, there's a real unknown creature out there. This is the opportunity to have that vetted in the right way. So I mean, if that is the case, and if we are sent quality samples of that species, we will find it.
Well, and I think that, and it only gets stronger once it is documented. Let's suppose at the end of your project, you've gotten X amount of samples, and there are 2 or 3 hits that seem to indicate that there is something there. The idea that if I partake in this project that I was going to be working on in the coming year, and we get 1 or 2 samples that show something similar, and I give them to you and they match yours, this is only going to start strengthening these efforts. I mean, one effort's going to be pretty conclusive to turn everybody's heads, but you start talking about once other people learn what you did and how you did it, and then they start realizing, okay, let's try to do that. And then all of a sudden they're coming up with sequences that are the same as the ones you found. This only gets stronger and stronger. I mean,
well, yeah, but I mean, the replication, yes, is important, but honestly, I mean, the initial finding itself would be that would be the important piece.
I think that you find one, it's pretty impressive. You find 2 or 3 from different geographical locations that have the same sequence.
Yeah.
You've Michael Jordaned it from the top of the key, and
that's what I said when I was on the show the other year.
I mean,
that would be the ideal. It's just as few as 3 samples from 3 different locations that shared
the same sequence.
Shared that sequence. That's wow. that would be a home run for the folks who are hoping to see a Bigfoot species found.
Well,
and the flip side of that too is
how does it affect the? I'm sorry. Go ahead.
No, I was going to say. I mean, you're probably going to ask, how does that affect research from there? Well, I mean, once you determine the sequence you need to look for, well, now you can create a primer that's specifically for that sequence. You can collect eDNA samples that are targeted for that species.
Here's a good example.
Now eDNA is,
one of the things I wrote about in my book was these two guys that recently discovered the last two species of butterflies. What they had done is they were working with a pretty advanced lab whose really their forte was insect, identification and things. It wasn't studying vertebrate mammals or anything like that. They knew what they were going to work in. They created a device about the size of a smartphone that had a probe on it, that these guys, when they found a sample, they felt like this was something that they hadn't seen before, that wasn't documented. They had reason to believe that this was an undiscovered species of butterfly. What that was loaded with was the DNA sequences of not for the whole world, because it would have taken too long to analyze each sample. For the area that they were in, all of the known species of insects and butterflies were in this device. So when they touched the wing of that butterfly and got a sample, it took about 2 hours for it to rifle through that threshold of known species of insects in that area, which probably were less than 1% of all the DNA genomic sequences for every living being on Earth right now. I mean, because that would just be so expensive. Still took 2 hours for that device to rifle through there and say this is a known species or it's not in this catalog. And they use that device. They'd test one and wait 2 hours, get the result, and go test another one. That's how they discovered the two last species of butterflies. Now, can you imagine if they didn't have to rifle through that, but instead had one genomic sequence in there? The one that, let's say, you found 3 samples of, I've found 2 or 3 samples of. It's just that one.
Right.
So
No,
when
absolutely.
we test anything, whether it's probing a blood spot, whether it's something in the field that you could use, and I'm not going through a library of 10,000 samples. I'm looking for one at that point. It would be kind of interesting to figure out. I mean, it could probably produce that result within minutes, So, and as this technology gets bigger and bigger, I mean, you look at what a smartphone could do 10 years ago and what it can do now. In a couple of years, we may be able, as field researchers and citizen scientists, go buy a device for $1,000 that we haul out in the field and it tests stuff like that. I think that's a very realistic thing that's on our near horizon, to be honest with you.
You're probably correct.
But, well, thanks so much, Darby. I really appreciate you coming on. I encourage people to go not only support the NC State project. I'll put the link so that you can go donate to that. Don't forget to ask your employer if you work for somebody that matches your nonprofit donations and you don't see them on the donation list. Let's double the power of whatever you're looking to give. But even more so, anybody who's got a sample, it may be something you've been staring at for a while. And maybe it's something that you just didn't feel like, I know when it comes to pictures and video, some of the best video that I've seen, Darby, is stuff that's never been released publicly. It's somebody
who for me.
They do not want to release it. They don't want people to rip them apart, call them assholes and everything else.
Yeah.
They're not interested in that. And so they sit on it. And there's some incredible video evidence out there that most people will never see because of what somebody goes through when they bring it forward. But I think when it comes to this, look, if you provide a specimen and it's tested, and in the end it ends up being bare or it ends up being whatever, there's no defeat in that. There's no embarrassment in that. You're simply trying to be part of a collective that could move this ball in a real way. And we're never going to get there if people don't take the time to say, I don't know what it is, but test it. And if it's not what we all hope it is, I'm okay with that. Just be okay with it. Go out and find some more stuff to test, at that point. But I encourage everybody to, if you've got something, to consider sending it in and having Darby and his team look at it.
And the first step is filling out that form. So
Yeah,
let's do that. And again,
it might
don't
be
worry.
your only chance in this lifetime to have somebody say, "I'll look at it for you in this way. I with this degree of precision and integrity, I'll look at it for you." You don't have to staple a $5,000 check to it. I don't know if you're ever going to get that chance to do it again. But yeah, I would also encourage you to staple the check to it if you can. Go ahead and staple the check.
But, I was going to say, don't sweat the form. I mean, again, don't worry about having to answer it perfectly or whatever. That's part of why we're asking for your contact information. Obviously, we have to have that in order to tell you how to submit the sample. But, we can ask you questions. We can, from there. It's not a big deal. The biggest thing is just making sure that if you've got something you think is interesting, offering it.
Can't win if we don't have the samples. Well, I appreciate you coming on, Darby. It won't be long, and we'll have you back. We'll we don't have to wait till the end of it. We can. I'd be excited just in a couple of months to have you back and talk about where you're at in the process, and if you're still looking for more samples at that time, or if you've had like some tremendous search of them sent in. But we can take the pulse here in a few months and get you back and get an update.
Yeah. And Jeff, you need to get to filling out that form, because I look forward to seeing what you have.
Yeah, I've talked about that, and I plan on sending a couple of the hair samples and a couple of the what I assume to be sebum samples or skin oil samples, because I'm interested in finding out what your results are. I'm going to send some of them in and have them tested with the project that I'm doing, but when it comes to something like this, if you've got a clump of hairs or something like that, it just doesn't make any sense to not provide a portion of them to at least get this process started, answering your questions. What do you have there, So, and like you said, you had the one deal where one lab said it was human and the other lab said it was wolf. It's like, boy, it doesn't pay to sit there and stare at it and wonder, because you aren't going to get anywhere.
I hope there's some people out there who have these interesting samples who are as curious as I am. That's what I have.
I've talked to a lot of people who claim to have hair samples and this and that. And I think now that people understand there is a way, there is a place to go, there is a direction to go with this, that when they come across something, that handprint on something that's way bigger than their hand or something like that, the idea of how to properly collect that sample, and not only that, but a place to actually send it to now, I think it may encourage more people to actually think that whole DNA speculative when it comes to evidence, and not just be staring at the ground for footprints and things like that. But thank you so much, Darby, again for coming on. I appreciate your time.
Thank you, Jeff.
Everybody enjoyed hearing from you, and we will have you on again shortly. All right. Appreciate you guys for tuning in and hanging on. There's still a few of you in chat. Hit that like button on your way out the door. I will thank you in advance for doing so. Other than that, we will see you next week on Monday. Take care.